Hello, this is Alan Elliott, and this is SAS Essentials, Mastering SAS for Data Analytics, 3rd edition. This is Chapter 20, Part 1, Creating Custom Reports. As we discussed in Chapter 1, the files that are used in this chapter, and you can download them, just go to this website where you can find the files. All right, let's get started. In this chapter, we're going to be able to create custom reports using PROC Tabulate, PROC Report, and also creating custom reports during the dataset. In this Part 1, we'll be concentrating on PROC Tabulate. So let's go to Section 20.1, using PROC Tabulate. Now, PROC Tabulate is used to make summary data tables that can handle multiple levels and rows and columns and provide summary statistics. Here's an abbreviated syntax for PROC Tabulate. We have PROC Tabulate and, of course, the normal options. And then we can define class variables, var variables, which would be numeric variables, a table statement where we can create rows and columns, and other options and statements. So we're going to be building a table by adding, we're starting off with a simple PROC Tabulate and adding things to it. For example, this simple PROC Tabulate statement defines a class variable, GP, and a table. So here we have PROC Tabulate, data is whatever data set, and the classification variable, GP, and we're going to create a table out of that variable, GP. Now, some common options for PROC Tabulate include, as we have seen in many others, the data statement, the out statement. The style specifies an ODS style format. The format defines the overall format for each cell. Order equal, we've seen that option, specifies the order the categories are displayed. And then missing specifies that missing values are to be treated as a category. Also, some common statements for PROC Tabulate. Again, many of these are common, but the var statement specifies typically numeric variables. The class variables are categorical variables. The table specification identifies the dimensions and other components of the table to create. We'll be concentrating on the table statement in this tutorial. And then commonly the by format, label, and where statements. All right, so let's take a look at that simple PROC Tabulate that we looked at before. So as we note, it's used to define what information will be displayed in the table. For instance, we're going to display the classification variable group in a table which is going to contain that variable group. So let's do something similar to that. Here we're going to define the class. Here we have the class statement where we're actually defining two classification variables, vname1 and vname2, and then we're going to create a table using vname1 and vname2. Notice here a slight difference, and sometimes it's confusing. When we list the class variables, there's no commas between the class variables in the statement. However, in the table statement, a comma has a specific meaning, as we're going to see as we learn more about the table statement. So in this case, it has a comma between vname1 and vname2. More about the class statement. So as we see, commas separate table dimensions. In the table statement, commas separate rows from columns, and an asterisk crosses two variables where categories of the second variable are expanded within the first. Thus, as we can see here in the table statement, we have vname1, comma, and then within this next section, we're going to have vname2 by vname3, which again expands the category vname3 within vname2. So this creates a table where the categories vname1 define the rows, and vname2 defines columns, and vname3 defines columns within the category vname2. We'll see these in examples. Okay, so let's examine the var statement then. The var statement identifies quantitative or numeric data. This variable can be used to indicate summary statistics in the cells, such as means, sums, and medians, and we'll have examples of that. So here we have a PROC tabulate where we have the class variables, just like we saw earlier, and now we're going to add a var statement, OBS. And OBS observation is a numeric statement. If we happen to put mean by OBS, in addition to this code, it would tell PROC tabulate to place the mean of OBS, broken down again by tables, vname 1, and then notice here, vname 2 by mean by OBS would create the mean of OBS within in the V2 category. All right, so let's look at the data set that we're going to be used. This is just a simple made-up data statement, data set, where we have a region. These are stores, which are either regular stores or kiosks within a mall. So we have areas north, south, east, and west. They're either upstairs or downstairs in the mall. They're either a store or a kiosk. And we have monthly data. In this case, we see some November data and the sales in thousands. So this downstairs kiosk listed first, its November sales was 33,000. So let's use that data set now to create our first table. So we say PROC tabulate data mysaslive.region, and here we have class type and data type. So very simple tabulation, and so it creates this little table that we see here, where the table is type, and then type is broken down into two items, kiosk and store, and then N says that it's showing us the count. So there's 27 kiosks and 45 stores within this data set. Now if we modify this and add in class statement type and area, and then ask for a table of type by area, then again we see that it starts out at the top with type, and then kiosk and store are the two types. But then it goes to area as the second variable, and area is broken down into the various locations, in this case east, north, south, and west. Again, the N specifies that we're going to have the count. So of the east kiosk, there are 9 of them. North kiosk, there are 5, and so forth. Now let's switch variables just to see how that changes things. Here again we have class, type, and area, but this time we say type area by type. And so in this case, area appears at the top. And again, we have east, north, south, and west. And then under area, type is expanded within area. So within area, we know we have kiosks and stores. So again, the east kiosk has 9 stores. And the east stores has 9, and so forth. So these are the counts. Now let's add a third variable to the table, and it is site. So here we have the classification of variables. So again, just to reiterate, if we're going to use a variable in a table that's a categorical variable, we need to or have to include it in the class statement. So in this case, we have type, area, and site. So notice here we have site by area by type. So site is the first variable listed in the table, so that appears at the very top. The site is either downstairs or upstairs, and then area. Area is east, north, south, west, and then the type, and the type is kiosk and store. And see, that was a very busy table, but nevertheless, you can see how we can build layers and layers upon tables to create the table or get the counts that we want. All right, let's change site by area to site comma area. I mentioned earlier that the comma has a special meaning to it. So if we change that asterisk, which meant by, to a comma, we say table site comma area by type. And notice here we get a different table. So I'm going to back up and show you the table we got originally. And then by changing site to site comma, what that did is it made the site into a row instead of a column. So here down by the row we have site, downstairs, upstairs, and then area by type is as we've seen before. where we have area broken down into its areas and then type broken down into its areas. So the comma then specifies rows and columns for a table. Now we can add labels and formats to variables as we can in most SAS procs. A label can be added to any variable by using the equal sign followed by a quoted string. For example, here we have table, site equals store site, area equal area by type equal store type. And then we can also format variables. So we can create a format definition for north, south, east, and west. If we want them to appear in that order rather than alphabetical order, we're going to now define a format we're going to call format compass, where n equal 1.north, s equal 2.south, east equal 3.east, and west equal 4.west. So that's what that's going to cause is it's going to cause the data to appear north, south, east, and west rather than in alphabetical order. So let's look at how we would do that. Let's open up the program file called atab2, and we'll notice at the top of this file we have this PROC format that we've just discussed, which is defining the compass north, south, east, west items. And then we have a PROC tabulate, and we're going to include the order equal formatted. If you remember from previous uses, that's going to display the data in the formatted order that we're going to then again define area format as the format compass. So that's going to cause the area to be displayed in order of its formatted items here, which we defined. So now we see how we get here. In area, we get north, south, east, west, which most people use that designation for compass points, so it makes the table a little bit easier to read. Otherwise, the table is the same as we've seen before. Now we can also report sums and means in the various columns and rows. To report the total sales, indicate the variable to sum using a var statement and cross that variable with a category variable in the table statement. For example, here we have var sales in K, sales in thousands, and here we have the table statement, table, site equals store type, area, and we have area, type equal type store, and then times or by sales K. So sum is the default statistic for this method, but we can request other statistics as we'll show here. For example, instead of the sum, if we wanted means, notice here the only change I've made is from sales K to sales K by mean. And what that will do is instead of reporting the sum value, it'll report the mean value. So let's look at the available statistics for the table statement, and these are commonly used statistics that we saw earlier. But we can do percent sum, column, percent sum, max and mean and min and all those kinds of things. All of these are available. So let's look at how we would use that. Open up the program called atab3, and here we have PROC tabulate. And all of these things are commonly seen here. The difference here is that we include the sales K here in the table statement, where we have type store by sales K. So sales K is going to appear as an expansion or as a summary statistic within type. All right, so here we have, again, the area and then the type store. And then notice here, instead of n, we have a sum. So that's how we've created something different. So if we had left that off, then instead of the word sum there, we would have had n, and we would have gotten numbers that were counts rather than these mean numbers here. So the mean downstairs north kiosk had an average of 63,000 sales. All right, now let's provide a label for sales. In fact, we're going to do it for mean sales. But so notice here in red, we're going to have, if we left off the label, it would just say mean by sales K, but we're putting a label in there in between mean equal. And so what that does is, notice then down in the resulting table, we have mean sales 1,000. So that inserts that label in there, and then the values reported are the means. 31.50 would be the mean sales for downstairs north kiosk, for instance. Now we can also add a format to that by adding F equal $6.2. And so now here's the same table, but notice the difference. I'll go back up one, and we had 31.5, and now it's a $sign 31.5. So we simply added a format to make that number a little bit more readable. We can do a number of other things to create better looking PROC Tabulate tables. So for an exercise, what I'd like for you to do is take the code that we have and change it a little bit by saying table site equal and then blank blank. So we're going to have no label for it, no label for area, no label for type, although we are keeping the label for mean here. And so by eliminating the labels, and actually we didn't have any defined, but defining blank labels, what that does is it takes away any labels that would have been there. And so you can see that we now have a much cleaner looking table. And again, I'm going to scroll up a couple just to show you what it looked like. So we had a very busy table, and now a lot of those, like area equal blank blank, so that took away the area label there and gave us a nicer looking table. So again, you can play around with those things, remove any unwanted labels that you want whenever it's obvious to you. So north, south, east, west, you would probably know meant the area that the store was in. All right, so let's look at hands-on exercise 20.4 and open up the program file atab4. Again, we're continuing to build on some of the things that we can do for these tables. And in this case, what we're going to do is we're going to add to the area equal blank blank, we're going to add the word all. Now this is in parentheses, so notice here area equal blank blank and then all. And the all option adds another summary column to the table. So again, let's take a look at what that does. And now at the end of the table, we see that we had the norm. This was the table, the first 4 columns was what we got originally. And now we have an all column. And so this 31.27 is the mean sales then of all of the downstairs, for instance, the downstairs kiosks. We can add another area, another all here. So table area equal all to note how the all specification was changed and area was moved to before site. So again, let me go up a little bit and see how site came first and then area. Now area comes first and then site. And what that does is it moves the area over to the left column, and also notice the comma there between area and site. Again, I'm going to go back up a couple ones and see that we had table, site, comma, area. Now we have area, comma, site. And so now the area is over here to the left, and we have an all. The all is now down here at the bottom rather than on the side. Now we can also have all in 2 locations. In this case, we have area blank blank equal all, or not equal, but just all, and then site blank blank all, both in parentheses. And so we're actually doing both now. Area, and then notice the comma here and the asterisk here defining how we want the table to look. But the resulting of this is that we get the all down at the bottom, as well as the all, the all means on the bottom as well as on the side. So again, you can play around with those things and put the values wherever you want them to appear in your table. There's other ways that you can enhance your table, so it's fairly easy to add information to your table. For example, suppose you want to report on more than one statistic, say in and mean. You can combine statistics by placing them in parentheses, such as in space mean. Or to eliminate the label, you can say in equal blank blank, mean equal blank blank. Okay, let's look at example 20.5. Open up the program called atab5.sas. And basically this is the program that we ended up with in the last discussion, where we had an all for both area and site, which resulted in this kind of table here, where we have all over here to the right and all in the bottom. So we had we requested the two alls in those two locations. Now what we're going to do is we're going to change the mean statement, which was right here, mean equal to n mean equal. So that what this is going to do is it's going to request two different statistics instead of just the one. So if we go back, we notice we have 32 as the statistic and 31.27. Those were means. And now notice we have 32 with a count of 1 and 31.27 with a count of 11. So by adding n and then mean, we get both statistics listed here. Now we can also, if you'll notice, this box over here doesn't have anything in it, but if we want to put something in that, we can use the /box equal fall sales. So all this does is gives a label to the blank box that's over here to the upper left in our table. So we can put whatever we want there, again, to provide more information in our table that makes it more readable and more understandable to whoever we're going to give it to. Now, we've created a table. A lot of times, you know, in corporations or in business or stuff, somebody always wants things in Excel. They don't have SAS, and so they want to have whatever you've created in Excel, so maybe they can play around with them and do something with it. Well, there's a way to save these tables that we've created to Excel, and the way we do that is with ODS, which we've seen in the past. In this case, we open ODS by saying ODS tag set Excel XP. What that means is we're going to open up ODS to Excel, and we're going to then create the body here into an Excel file. We run whatever PROC tabulate we want to run, and then we close the same one. It's just like when we said ODS HTML and ODS close HTML. So that's all we have to do, put that before and after our PROC tabulate. And here is an example of that. So open up the program file atab6.sas, and we see that we've done that where we created the ODS statement above here, and we have the ODS statement down here, and then within or between those, we have a PROC tabulate statement. So what that did is it created in Microsoft Excel, we can see that now we have the same table we created in SAS, except now it's in Excel, and you can see that you have the column names and the row names here. So once you do this, then somebody can open this up in Excel and use it to their heart's content, to whatever they want to do within Excel. All right, well that concludes PROC tabulate, and so we're going to continue with Chapter 20 to look at some additional ways to create reports. And so hopefully if this was helpful to you, please subscribe to this channel and like this tutorial. All right, we'll see you next time. Thanks.